Okay, number one, find the sum of the infinite series. Well, looking at that, let's go to the whiteboard, all right? Keep your notes in your hands, though, because you want to be able to look at the numbers, all right? Let's go to the whiteboard and write the sum down. And again, they said there's a detectable pattern to this over here, and I'm looking at it, and I do see the pattern, all right? But let me write this down for you. It's number one, and I do see the pattern at the top is 1, then I see this at the top, plus 2, plus 3, plus 4. And the bottom, I'm seeing 2, I'm seeing 6. More difficult pattern, by the way. I see 24, and I see 120. But then they put this telltale sign of dot, 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 that goes on forever, that they claim it's a predictable pattern over here. So kind of looking at it, I'm going to write it, this is a sum. It's an infinite sum, by the way. I'm going to summation notation. I'm going to start at 1 and go off to infinity. And the top, I'm going to say, is pretty easy, just to end. The bottom looks like a factorial to me, though, all right? So, like 1 factorial, 2 factorial, 3 factorial, 4 factorial, so forth and so on. 1 factorial, by the way, 0 factorial could also be written down as 1, 1, 2, this is going to give me 6, this is going to be 24, 5 factorial would give me 120. What am I noticing? It has something to do with the factorial. There's no doubt about it. But I'm noticing it's starting at 2. And let me write this down, n plus 1 factorial. And then I get to 6, 24, and 120. So I'm going to claim that's my sum. Now, we've seen this before in a prior section of this, the challenging problems here. But I want to put out what we did in the past. We wrote this down. We wrote down S1, which is just simply 1 over 2. It's the first term, by the way. We wrote down S2. That's 1/2 plus 2 over 6. Now, when I say I think we did this before, I really do think we did this before, by the way. And what's it going to be? 1/2 plus 1/3, which is a sixth. And then when you get there, 3 plus 2, which is 5. Then when you get S3, what's that going to be? 1/2 plus 2 over 6 plus 3 over 24. Well, we already did the first two terms. That's going to be 5/6. And 3 over 24 is 1/8. Column down there would be 24. And let's see, that would be 4 times 6 is 24. So you get 20. And 3 times 8 is 24. That would give you 3. You get 23 over 24. All right? What's the next one going to be? S4. And you get, 1/2 plus 2 over 6 plus 3 over 24 plus 4 over 120, which is going to be, well, we already did the first three terms. It's 23 over 24 plus 4 over 120 is going to be 1 over 30. Comma down there would be 120. Let's see, that's going to be 5, right? So 5 times 23 is 115. 115 and 4 times 30 is 120. So 119. All right? And then we said, oh, gee, you could basically predict on this over here that Sn would be what then? All right? So let's think about that. It would be, it has something to do with factorial, doesn't it? So it's going to be, looking at it, it looks like the bottom is going to be n plus 1 factorial. And then the top is going to be n plus 1 factorial minus 1. That's the pattern, by the way. So the way I'd write this over here, well, at least probably write it down as, so I could think about it more clearly. Let me just go backwards a little bit. I'd probably write it as 1 minus 1 over n plus 1 factorial. And then I look at this thing over here, take the limit, and this is a recognition of a pattern, by the way, n goes to infinity of Sn, and what would that give me? It would just give me the number 1, all right? So I'm going to say we sort of did that before. But what I want to do is I want to do it differently. All right, so what I'm going to do is write down things that, it sort of reminds me of e to the x. So this summation kind of reminds me e to the x, right? And again, this is 1/2 plus 2 over 6 plus 3 over 24 plus 4 over 120 plus yada, yada, yada. It goes on forever, all right? But let's write this down. E to the x, again, it kind of reminds me of this. What's it going to be? 1 plus x squared over 2 factorial. But this is 1 factorial. That would be 0 factorial. All right, it sort of reminds me, because see these factorials in the bottom. Then you get x cubed over 3 factorial. Then you get x4 over 4 factorial, yada, yada, yada. All right, sort of reminds me of that. All right, the problem is I'm not seeing the tops, though. All right, so what I'm going to do now is I'm going to write this over here, e to the x over x. Now let me write this down now. And what are you going to get? You know, the first term would be 1 over x. Then you get, again, I'm dividing these terms by x, by the way. Then you get 1. Then you would get x over 2 factorial. Then you would get x squared over 3 factorial. Then you would get x cubed over 4 factorial plus yada, yada, yada. It goes on forever. Right? I'm going to differentiate that now. So d dx. Again, I'm trying to find this in the pattern, by the way. And I'm going to say that it's like differentiating both sides. All right, let's take a look at it. Well, the left side's the easiest one for me to do. It's really going to kind of peter out pretty quickly. It's x squared. Then it's going to be x times e to the x. Let me think about this. I'm using the quotient rule. Square the bottom, bring the bottom to the top, multiply the derivative of the top, minus the top, which is e to the x, times the derivative of the top, which is 1. That was simple. All right, let's do the other side. And I want to make 1 over x is the same thing as x to the minus 1. So what do you get there? You get minus 1 over x squared. That's done. The derivative of 1 is 0. I'm not going to write that down. The derivative next term is going to be, let's see, that's going to be 1 over 2 factorial, right? What's the next one going to be? 2x over 3 factorial plus 3x squared over 4 factorial plus yada, 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 yada. All right? I'm kind of looking at this and I'm still wondering, is this going to produce what I want up here? And I think it is. I'll tell you why. If I let x to be 1, so I'm going to set x to be 1 now. What are you going to get? Let's write this down. Let's do the left side first, though. What are you going to get? If you set x to be 1, on the left side, you would get e to the 1 minus e to the 1, which would be 0, over 1, which is 0. Let's do the other side, though. What are you going to get? Minus 1, that's the first term, plus 1 over 2 factorial, plus 2 over 3 factorial, plus 3 over 4 factorial, plus yada, yada, yada. We're going to do an add 1 to both sides. You get 1 equals 1 over 2 factorial, plus 2 over 3 factorial, plus 3 over 4 factorial, plus, I think you get the idea. What sum do we have over here? This is the sum, n equals 1 to infinity. That's going to be n. Again, we get that 1, 2, 3. And what do you get in bottom? It's actually n plus 1 factorial, which is what we wanted. And we want to show it's 1 anyway. It is 1. Thank you.